Oh, so today we're going to look at graphs of functions. I'm not going to look at logs or exponentials. This is going to be just your kind of cubic functions, um, your turning point type equations. So first of all, we'll do a little kind of general introduction here, and then I'll go into what I think are the biggest type of questions you're going to get. So these are manipulating the graph and moving it up, down, left, right. And then these ones, I've got a little bit more chat about maybe a differentiated graph or working backwards. Okay, so slightly trickier questions. These are your standard questions, just moving the graph up, down, left, and right. So yeah, we're I'm sorry, I've got a wee cough just now, so that might be fun. And I'm not sophisticated enough to have a cough button. You just have to bear with that, sorry. So if we've got a function, f of x, y is equal to f of x, we can manipulate it by putting in a k value. So this top row, this is going to affect my y values. So right now, if I was to put in kf of x, this is me multiplying my y values. If I do plus or minus k, this is me adding to the y values. Okay, so this top row is the y values, and in here we're affecting the x values. So kx is going to multiply by the x, but we'll come back to that, and this is going to plus or minus k from the x values. Okay, so first of all, that's the most important thing to think about. The k on the outside of the bracket affects the y's. Okay, so see k is outside the bracket. Let me just highlight that actually. Okay, so k is outside the bracket. Okay, I'll use a purple pen just to keep this as close as I can get. Okay, so outside the bracket affects the y. Okay, outside the bracket, changing the y. And on the bottom there, you can see that when k is inside the bracket, it affects the x. I shouldn't use yellow because I've got to use yellow. So inside the bracket, we're affecting x. So if you can get that into your head, first of all, that's a good position to be in. Outside this bracket, I'm moving y values. Inside this bracket, I'm affecting x. So how does that actually work? Well, let's look at this bit first. All I do here is I take my y and I times it by k. That's all that's happening. Okay, so if this is 2, I'm going to multiply all my y values by 2. If this is 3 times 1 by 3. If it's a half, I'm going to half all my y values. I'll times it by half, so divide by 2. Over here, I'm saying that if I'm adding k, my graph goes up because I'm adding to y. If I'm taking away k, my graph goes down. That's adding to y, that's taking away from. As a little aside, let's just do a little example over here. So say we put them all together. If I've got y is equal to 3, 3 f of x plus 2, that means that a coordinate, say the coordinate was 2, 4, that would now become 2, x just stays the same. The y value is going to be times by 3 for 12 and add 2 for 14. So to get from here to here, I've had to times by 3 and add 2. So outside the bracket, we're dealing with y's. Inside the bracket, we're dealing with x's. I'm going to do this one first, it's a bit easier. The first thing you want to note with this, with the x's, is that we generally do the opposite. Okay. Up here, it's nice and straightforward. We times by k, we add and subtract k, so add goes up. This is kind of back to front now. So if I'm adding k here, or taking away k, you might think, all right, add k, that's going to the positive side of the axis, but no, we're actually going to go left, and take away, we're going to move right. So we're doing the opposite of what we'd expect. Yeah, so adding on 3, so adding on k, moves us back 3. It sounds a bit confusing, doesn't it? So what happens here is I've got x take away k, and here I've got x plus k. So you do the opposite to x as to what's in the bracket. So adding on k moves us to the left, taking away k moves us to the right. And finally, This again, we're doing y, but instead of y times, sorry, x, we're doing x. But instead of x times by the k, we're effectively dividing it by the k. We're doing the opposite as to what's in here. So if this is 2x, we're going to divide by 2. Okay? If this is a half x, that means we were dividing by 2. So now we're going to times by 2. So we're doing the opposite in the brackets. So let's just do a little example over here. So let's say we've got y is equal to f of, let's say, x take away. So if I've got a coordinate, say my coordinate again is 2, 4, well, the y just stays the same because, oops, I'm writing y. The y stays the same because we're not affecting the y, we're inside the bracket. But this time, the 2, I'm doing the opposite of what's in there. That's going to become 5 because I'm adding 3. And that makes sense, doesn't it? Because we said the takeaways move it to the right. So the takeaway moves it to the right. I've gone from 2 over to the right until 5. If I was to say y is equal to f of, I'll do a tricky one, I'll say a half x. I'll do it with a 2, 4 again. So y just stays the same. Tell me why. But the x this time, so we're doing the opposite. So here, this is effectively divide by 2, isn't it? Because a half times something, if I say a half, times by 4, that's the same as a half times 4 over 1. So 4 divided by that will become 2. Yeah, we're effectively dividing by 2. So instead of dividing by 2, I'm going to times by 2. So this is going to become 4, 4. So you always do the opposite to what's in there. If that was a 2, I'd be dividing by 2. Let me just show you that actually. So say we had f of 2 of x. We've got our 2, 4. That's going to become 1 and 4. Y stays the same. And I'm dividing by the 2. Okay, so that's maybe a lot to take in actually. But let's just recap. Outside the bracket, we're moving our y values. If it's next to the function, we're multiplying. If it's at the end of the function, it's an add, it's an up or down. You just add or subtract. You do exactly as the case is. Okay, this is k times by that function. This is this function plus or minus k. If it's inside the bracket, we're moving the x's, and you're effectively doing the opposite. So if that's a half, you're timesing by 2. If it's a 3, you're dividing by 3. You're doing the opposite. If this is plus k, you're taking away k. If it's negative k, you're adding k. Do the opposite. And the only thing I've not talked about is the negatives. A negative would flip it. So if I put in a negative k here, that's going to flip it around my axis. I'll just very quickly show you that. So if I had a function doing something like this, if I was to take the negative k, it would just be reflected about the x-axis. Yep, so that would be f of x. That would be f of negative f of x. Yep. So reflect this, and this one does the same actually. So if, we reflect it, this time reflect at the y-axis. If we had I had something doing something quite nice. I hate doing these reflections. I'm not very good at them. So we're reflecting about this axis this time. So it's going to be something like, something like that. Okay, so you're reflecting about the vertical. So that's something that can confuse people. Okay, so that's the time when you just do what it says. If you've got a negative in here, you just make it negative. So yeah, reflecting about this axis and reflecting this. So I thought that's a good introduction. We'll start and do a few questions next, but if you can remember all those rules, and when you start breaking it down in your head, you have to remember all individually. They kind of flow a little bit. You're doing the opposite for these two. Inside the bracket is x, outside the bracket is y, and I just do what I'm told with the y. Suddenly you're thinking, okay, I could remember that. Maybe write this down when you start one of these questions. And yeah, that's good to go. So we'll start on these on the next video. Hope to see you then.